Okay, we're going to look now at using integration. So the same way as we had to use differentiation to find turning points and tangents and normals and maximum minimums, we'll have to use integration. And we use integration to find the area under a curve. So we have some curve y and it's a function of x. So in other words, it's y equals something with x's in it. And we're going to find this shaded area here between a and b. And this is our rule. The area is the integral between a and b of this function of x with respect to x. So this is just like your definite integration. So we'll do 3 questions. We'll start with a very basic question. Find the area under a curve y equals x squared minus x minus 12 between the lines x equal 0 and x equal 2. So we just write down the area equals the integral between 0 and 2. Remember, our smaller number goes at the bottom, our bigger number goes at the top. And our graph, our function of x, is x squared minus x minus 12. And we're integrating that with respect to x. So it's a definite integral now, so add 1 to the power, divide by the new power. I'm going to put squared brackets, add 1, divide by the new power, our 12 becomes minus 12x. Move our limits to here, and remember we don't need the plus c because it's a definite integral. So put in 2 then. So we have 2 cubed over 3 minus 2 squared over 2 minus 12 times 2, and then subtract and put in our bottom limit. Now when we put in our bottom limit, we get 0, 0, 0. So we're just subtracting 0. So we have 8 over 3 minus 4 over 2, so that's 2 minus 24. Now that turns out to be minus 23 and a third. Now this is looking for an area, so obviously we don't want a minus here. The reason that we have a minus is because this graph, do a very rough sketch, we're looking at the area under this graph between 0 and 2. So something like that. So our area is below the x-axis, so that's what this minus sign means. So we say our area is 23 and a third. Now there's no real units for this because it could be squared centimetres, it could be square metres, it could be square kilometres. It depends on the scale you do your graph. I tend to write square units, so it's showing that you know that it's squared. And sometimes in exam you'll see part of the question could be what's the significance of the minus sign? Why have we got a minus sign? And then we need to know it's below the x-axis. Okay, so our second one then is looking at quadratic graphs. So part A, sketch the curve y equals x squared plus 3x minus 10 and find the area between the curve and the x-axis. Now usually when you get a question like this in an exam, it leads you through. So we did questions like this when we were doing differentiation. It leads you through and it'll say where does it cross the x-axis, the y-axis, what are the turning points, the nature of the turning points, then sketch the graph, and then this last bit, find the area. So we'll do out the whole thing. So y equals x squared plus 3x minus 10. So let's first of all do what happens when x is 0. Well, y is going to be 0 plus 0 minus 10. So we get that y is minus 10. So there's our first coordinate then where it crosses at 0 minus 10. Then say, well, what happens when y is 0? We get 0 equals x squared plus 3x minus 10. So we need to factorise, and we get x plus 5 upon x minus 2. Now this one factorises, remember it could be using the quadratic formula as well. So x is minus 5 and 2. So there's our next coordinates, minus 5 0 and 2 0. So we've got all the coordinates of where it crosses the axes. The next bit then are the turning points. Our turning point, obviously, because it's just a quadratic. So whenever you think turning points, you have to think we're going to differentiate. So if y equals x squared plus 3x minus 10, dy by dx is going to equal 2x plus 3. And this is where you have to make sure, because there's differentiation and then there'll be integration later in the question, don't confuse the two. Okay, so be very clear, we're differentiating here. Okay, so for a turning point, dy by dx equals 0. So we get x equals minus 3 over 2. Let's make sure that it's, well, we know the shape of the graph, it's positive x squared, so we expect to get a minimum, but let's just make sure by differentiating again, and we get 2, that's greater than 0, therefore it's a minimum. We've got the x coordinate of the turning point, and now we need to find the y coordinate of the turning point. So when x is minus 3 over 2, y is going to be minus 3 over 2 squared plus 3 times minus 3 over 2 minus 10, and we get that the y coordinate is minus 12 and a quarter. So there is, at minus 3 over 2 minus 12 and a quarter, we have a minimum turning point. So we're going to use all of these points to sketch our graph. And this is where you'd be given in the exam usually just a blank set of axes, and you have to try and draw your graph on, not exactly to scale, but the more you sort of draw it to scale, the easier it will be to draw. So it crosses at 2 and minus 5, and the turning point is minus 1.5 and down to minus 12 and a quarter. I know it crosses this axis at 10, but I'm going to draw the curve first and then mark on 10. So again, you should find this easier to draw because you don't have this camera in the way. And it should be a nice smooth curve. And that's 10 there. And then the question for part B is asking you to find the area between the curve and the x-axis. So we are looking for this area here. Okay, so this is then part B. The area, this time we're integrating. Now we can see on our diagram it's between minus 5 and 2. That's our limits. So from minus 5 to 2, and our equation of our graph is x squared plus 3x minus 10, and we're integrating that with respect to x. So add 1 to the power, divide by the new power, add 1, divide by it, minus 10x. And remember then, we don't need a plus c because it's a definite integral. We put in our limits then. So we have put in your top one first, so we've got 2 cubed, that's 8 over 3, plus 3 times 4 over 2, minus 10 times 2, so that's minus 20. Take away, and then put in minus 5, so get minus 125 over 3, plus 3 times 25 over 2, minus times a minus is a plus, 50. Okay, and then we work out our 2 brackets. And our first bracket turns out to be minus 11 1/3, and our second bracket is 45 5/6. So it's minus 11 1/3 minus 45 5/6, and we get minus 57 1/6. And look at your diagram from part A. You would expect it to be a minus because we're looking at an area below the x-axis. So then our answer, we're going to say that the area is 57 1/6 square units. And again, if you're asked in the question, why is there a minus sign? Because it's below the x-axis. Okay then, and our last one is the cubic graph then, which is obviously just a wee bit harder than the quadratic. So sketch the curve. Again, this would be the first part of your question that we've already looked at with all the differentiation. And again, in an exam, it'll break it down a bit and say what happens when x is not, y is not, and so on. So the first thing then, let x equal naught, and you get that y equals naught. Would have naught, naught, naught. So there's our first set of coordinates. Then what happens when y is naught? We get naught equals 2x cubed minus 3x squared minus 72x. Take an x out, and we get 2x squared minus 3x minus 72. So either x is naught, which we already have up here, or 2x squared minus 3x minus 72 equals naught. Now this, unfortunately, we can't factorise, so we're going to have to use the quadratic formula to find the values. So x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we get our two answers, and the question said to give your answers to two decimal places when needed. Our two answers turn out to be 6.80 and minus 5.30. So our coordinates then, 6.800 minus 5.30, and we already had the 001 from the first part. So there's our 3 points where it hits the axes. Okay, so then we want to look at the turning points. Now remember, this is a cubic, so it's going to have 2 turning points. So if it's a turning point, remember y was 2x cubed minus 3x squared minus 72x. We're going to need to find dy by dx. So remember, this time we're differentiating. So we get 6x squared minus 6x minus 72. And then for turning points, dy by dx equals 0. So we let this equal 0. And then we've got a quadratic to solve. I'm going to divide by 6 to make it easier to work with. And we get x squared minus x minus 12. Now we can factorise this. And we get that x is 4 or minus 3. Okay, so we need to then find the y values, and we also need to find which one is maximum, which one is minimum. So we'll first of all we'll get d2y by dx squared by differentiating our dy by dx. So we get 12x minus 6. So we'll take each of the x ones in turn. So x equals 4. When we put that into our equation for y, we get 2 times 4 cubed minus 3 times 4 squared minus 72 times 4, and that turns out to be minus 208. And put into d2y by dx squared, we get 12 times 4 minus 6, and we'll get that that's 42, which is greater than 0, therefore a minimum. And then when we put in x equal minus 3, we'll have to find our y and then our dy by dx. So it's 2 times minus 3 cubed minus 3 times minus 3 squared minus 72 times minus 3. Put that all in and we'll get 135. And then our d2y by dx squared, that is 12 times minus 3 minus 6. That gives us minus 42. That's less than 0. Therefore, it's a maximum. So our turning points then, just to summarise them, 4 minus 208 was our minimum. And minus 3, 135 is our maximum. Now we're going to try and sketch this. Now, like, they're ridiculous numbers to put on a scale, so your diagram is not going to be perfect for this one. Well, my diagram is definitely not going to be perfect for this one. So we've got our axes. Now it crossed, in the first part of the question we found it crossed at minus 5.30 and 6.80, and at 0 our turning points are minus 3 and 135, and that's maximum, and then plus 4 and minus 208, and that is our minimum. Okay, so we sketch the curve again. You should be trying to make it into a nice smooth curve, which should be easier to do on your page when you don't have a camera in the way. And it looks something like that. Then part B asks for find the area between the curve and the negative x-axis. So this is a negative x-axis here, so this is the area that we're looking for. Now, if you were having to find the whole area, you would have to divide it up and find this area and then this area and then add them together, because they're two separate spaces. You couldn't just integrate the whole thing, but we're just looking for this area. That's all we're asked for, and we're integrating between minus 5.30 and 0, and our graph is 2x cubed minus 3x squared minus 72x, and that's what we are integrating with respect to x. Now we'd expect this is above the x-axis, so we'd expect to get a positive number here. So add 1 to the index, divide by the new index, add 1, divide, add 1, divide. Remember, you don't need the plus c because it's a definite integral, and this is between minus 5.30 and 0. So this time we put in 0 first, and we get 0 minus 0 minus 0, so it's just 0, minus a half times minus 5.30 to the power of 4, minus 5.30 cubed minus 36 times minus 5.30 squared. And that turns out to be minus 467.84. So we have 0 minus minus, so that becomes a plus. So our area is 467.84, and it's positive just as we suspected.